Good afternoon.
Good afternoon, ma'am.
So now we'll do last class we have done a problem on pre-stress bend tendon. We simple bend tendon without an eccentricity, but now we will solve a problem of eccentric tendons in bend tendons. Okay. So without wasting time, let's share the screen. So this is the next question, and this is the figure. Yeah, this was the last question. The answer we had this thing. Okay, and the stress diagram. This were the stresses at the top. The topmost fiber stress was in compression. We had tension in the bottom fiber with minus 0.4 Newton per mm square. And the if I show you the stress diagram of this was in this way. The last sum which we had done, the last problem which we had done, this was the this was the figure, and here we have the stress diagram, which is here you see the total stress was what? Total stress was plus 10.4 Newton per mm square, and we have bottom stress was how much? Minus 0.4 Newton per mm square. That means in this particular question with a bent tendon, it was compressive stresses are there at the top, and at the bottom most there is some tension here. Okay, there is some tension here at the bottom of minus, or that is of zero point 0.4 Newton per mm square. Now in this question, next question, this one here, write down the question. This figure shows a pre-stressed concrete beam provided with bend tendon. This is also a bend tendon like the same previous question. But here in this particular question, what is happening? You can see here. You will see here. This portion here, there is eccentricity at the end portion. At the end portion, there is eccentricity. These are your eccentricity. Earlier in the previous question, what it was? Your bend tendon was this one here till the CG of the concrete steel. Okay, so now in this particular question you have the external load, point load is given to be 160 kilonewton, this one, and then determine the stress distribution for the end section and the mid section. In this question you have to calculate all the stresses at the end section as well as at the mid section as well as at the end section. The dead load of the beam is 6 kilonewton per meter. That load is given, so you can calculate the UDL. You can calculate the UDLs. This is your point load, 160 kilonewton at the center. So you have to find out here your at the center here your stresses at the top and bottom, as well as now in this question at the end section here you have to calculate the top fiber stress and the bottom fiber stress. Here also top stress, bottom stress. Here at the midsection also the top stress and the bottom stress. So how we used to proceed? We have to, in the bend tendons, we know in the bend tendons we have 160 kilonewton. So like in the previous question, you have to calculate the this thing, the upward thrust here, The upward thrust, what was that? That was 2p sine theta, and that is nothing but 2p tan theta when theta is very very small for us. So we have our upward thrust is 2p tan theta and theta. So that is how much we have to calculate for that. The tan theta, first of all, calculate the tan theta. What is your tan theta here in this case? Anyone? Tan theta here?
100 by 3000, no, ma'am.
No.
50 by
Anyone? Uh-huh.
3000. 50 by 3000.
No. In the previous question, what we had done, we had taken this half section, this half portion we had taken, and then the tan theta we had calculated. Tan theta, what is here now? In this, if you see this tendon, the left hand side tendon, you see from this center to the left hand side of the tendon, what is the profile? Hmm?
50, ma'am.
Mhm. At the we are finding out what here you
10
see.
theta, no, ma'am.
Tan theta. And what is our tan theta? For what we are finding the tan theta? This tendon, this one. Hmm. So this portion we are finding out tan theta for this. If I say you this one, this from here to here. That means how much? Tan theta is perpendicular. This
150
perpendicular distance is how much?
150,
150.
no, ma'am.
Yeah, because 100 plus your this 50.
Plus 50.
Yeah, so 150 divided by your this base is how much? 3000 here, because this entire was 6000, so this is 3000. So this will be your tan theta. Tan theta is how much? 150 divided by your 3000. Okay, so that gives you to be 15 by 300 here. This one you will get tan theta, you will find out the value. Then 2p tan theta you can find out now. Once you know your tan theta from this figure, when you know in the bend tendon, what is a 2p tan theta now? P is already known to you. This one, pre-stressing force of 1000 kilonewton. What is your 2p tan theta now? Calculate.
300 kilonewton, ma'am.
300 kilonewton.
Oh, no, ma'am. No, ma'am. 150.
How much is a 2p tan theta? After calculation, pre-stressing force, this one, 1000 kilonewton.
100.
Sure, 2p tan theta. Everyone, where is the comment chat? Okay, 100. Everybody got 100. Type in the chat box, I can see, so that Rovila 100. Others 100. 100. That means it is 100. 2p tan theta is your 100. So now once you know your this upward thrust, then you can find out what is your net load. Net load will be how much? 160 minus your 100. So that will be 60 kilonewton. Your net load now, the point load, due to this external load 160 and the upward counterbalancing by the upward thrust 2p tan theta, your now the load which is falling on the beam is 60 kilonewton, and also we have the dead load given to us. Dead load was 6 kilonewton. This one 6 kilonewton per meter here. Meter. So now we can find out, similar to the previous question, we can find out the moment due to your point load. Moment due to point load. Due to this is WL by 4. WL by 4. Calculate that. What is your WL by 4? W is your now 60 kilonewton. So 60 kilonewton into 10 to the power 3 it will be. So calculate this W 60 kilonewton, and your spine is 6 meter divided by 4. How much is your value? Just tell me then in the comments, in the chat box. You just type the answer for the dead load, sorry, point load moment, and the moment due to, I write dead load moment. Dead load moment is WL square by 8. WL square by 8. So how much is your this moment due to the point load? Moment due to the point load, Himal is 90 kilonewton meter. And the this one, the dead load moment, moment due to dead load, Rebecca 90, Romila 90. Now the dead load moment, how much? 27. Okay, I take it to be then 27 kilonewton meter. So we got our dead load moment and the moment due to this point load 90 kilonewton meter. So once we know the loads, we can find out the moments. Now total moment will be this plus this 90 plus 2, sorry, 27. So this is our final total moment, dead load plus point load moment. Now, in this question, you are asked to find out the distribution of stresses for the end section. For the end section. Now, in the end section here, in this particular end section, we have to find out the stresses. So, what will be the stresses present at these end sections? What do you think? What will be the stresses here?
Stress due to tendons and stress due to eccentricity.
Yeah. So because eccentricity is here at the end section, so now the stress due to eccentricity is going to come. But one more thing, okay, what is that? P by A? P by A. Now P by A, our next is our what? Stress due to eccentricity. Moment is 0 here, so that will come to be 0. Now this symbol, it is going to be what? For the stress due to eccentricity, plus minus PE by P PE by Z. PE by Z. Okay, because now in the previous questions what we were doing is minus plus PE by Z, because our CG was here, and the eccentricity of the tendon was below the CG. But now in this case, in the eccentricity in this end section here, our CG is here, this one at the center, and our eccentricity is at the top. Yes or no? So what will happen? Our moment will be this way. So it is compression at the top and tension at the bottom. So it is PE by Z. Okay. So now calculate what is your total stresses at the end section. At the end section, what is your total stress? P by A. P you know. P was what? 1000 kilonewton. Area you know. The section is given 400, 600. P E we know. How much? Eccentricity by Z. Calculate and tell me the stresses at the end section. At this end section, what is the top fiber stress and the bottom fiber stress? Tell me. Calculate and mention in the chat box. Which is your P by A. Till then, let me your attendance. Otherwise, I'll miss this also. 31st. Rahul Barwa, 44. While solving, you also give your attendance, please. 44, 64,
64.
65,
Ma'am.
67,
Present, ma'am.
69,
Present, ma'am.
70,
Present, ma'am.
72, Manhaka, 72, 73,
Present, ma'am.
74,
Ma'am, 75.
75. Okay, 74 present. 75,
Yes, ma'am.
76, 77,
Ma'am,
7.
77. Present, ma'am.
Okay, 77, 78.
Present, ma'am.
Ani Akash. 7.
72.
Ma'am.
Huh?
Ma'am.
72 Manhaka.
Ma'am.
Hmm.
Ma'am, 76. Present, ma'am.
76. Okay. 81, 81, 82, 82, 83,
Present, ma'am. 83.
84,
Present, ma'am. 84.
85,
Yes, ma'am. 85.
87, 80, 88, 88, 89, 90, 91, 92, 93,
Present, ma'am.
94,
Present, ma'am.
94 present, 95,
Present, ma'am. 95.
96,
Yes, ma'am.
when I call your enrollment 96, then you please, if you're present, you say 96, okay? 96?
96. 96.
Okay, 97, 97, 98,
98, ma'am.
98, 100, 102, 103, 104, 105, 107, 110,
110, ma'am.
okay, 112,
112, ma'am.
okay, 115,
115, ma'am.
116,
Ma'am, present.
117,
Present, ma'am. 117.
okay, 119, 21, 121, 121, 122,
122, miss. 122.
122, okay,
Yes, miss.
123,
Yes, ma'am.
122 present, 123, 123, 125, 126, 127, 128, 129, 130,
130.
okay, 132, 135, 137,
Yes, ma'am. 137.
okay, 139, Taraland, 140, Biru Jamatia,
40.
140, 142, Nabam,
Yes, ma'am. Present, ma'am.
147,
Yes, ma'am.
Tani Talom, Michael, one integrated one, yes. 2, Tasika,
Michael is present, ma'am.
yeah, Tasika, Laishram,
Present, ma'am. That's from.
Tosin, Tosin, Tasika and Tosin are absent, okay. 142 present, 130 is present, 132, 32, 121 present, 98, 98, 95, okay, done. 93, 81, 92, 93 given to 81 is also Lopsam present.
Present, ma'am.
72. Okay, okay. Okay, done. How much is your answer? Top fiber at the end section. What is your top fiber stress?
6.25, ma'am.
Yes, 6.25 Newton per mm square. And at the bottom,
2.1, ma'am.
2.09. Yeah, that's it, 2.09 Newton per mm square. Correct. So you know now these are your end sections. Stresses at the top and the stresses at the bottom at the end section. So stress diagram, that means this is your stress diagram, right? P by A is your 4.17 Newton per mm square. You have your PE by Z to be 2.08 Newton per mm square, and that is why your total stress at the top is 6.25 Newton per mm square, and at the bottom it is 2.09 mm square Newton per mm square. So that means what? At the end section, the entire this beam is in compression, because plus sign, it is the compression at the top with 6.25 Newton per mm square at the top as stress, and at the bottom 2.09 Newton per mm square. Now if we have to go to the if we have to check the stresses at the mid span, what you are going to do? Can you calculate the stresses at the midspan now?
Yes, ma'am.
Yeah, calculate the stresses at the midspan. We already have calculated the the net load we had calculated. Then we have we now know the moment, bending moment due to the dead load, due to the point load, total moment we know, Z we know, A we know, tan theta we know how much. So it is easy for you now to find out the stresses at the midspan section, P by A. How many stress? What type of stresses will be here now at the midspan here?
3, ma'am.
P by A.
P by A, M by Z, and E by Z.
No. How much? How much was our upward point load? That means the 2p tan theta, how much it was? 100 Newton, 100 kilonewton. Net downward load we got to be 60 kilonewton. Then we have bending moment 90. Eccentricity was how much? Due to eccentricity, calculate. Meeting is going to end in 5 minutes.
Ma'am, I have a question, ma'am.
Hmm.
And please, if there's still time, can you explain the difference again, once again, between this eccentricity distance between the first case and second case?
What?
If there's still
Eccentricity
time,
what?
can you
Your
repeat
voice is
this?
breaking.
Can you repeat this eccentric distance for this first case and second case?
Eccentric distance. Here.
Yeah.
Yeah. Here in this earlier in the previous question when we had done, what was the tendon was in this way from the center of CG like this. So at the end we have an eccentricity of this, and due to this eccentricity there will be a moment in this way. This one, like this, like this. So that is why in the upper portion of the end section there will be compression, and at the bottom there will be tension. But in the previous concentric tendons without bend tendons, what was that? Your eccentricity was at the bottom here, bottom, and your CG was above, the center of the beam was at the above CG. So in that case our bending moment was in this way, this way, this way. So it was tension at the top, and at the bottom it was this thing, compression. So we used to write minus and plus here. And now in this question, when you have to find out the stresses. Suppose in the midspan section, now what are the stresses that will be developed here will be in this particular center. One stress due to the pre-stressing, you all know, which is uniform P by A direct stress will be present. Another one is your due to this loads, due to this loads, which is your that load, net load, which was this minus your upward thrust, that load, net load, and also your load of the dead load of the beam, ws square by 8. And also there will be a moment due to here at the center there will be a moment due to this, due to this effect of this eccentricity 50 mm. Due to this eccentricity, here will be a bending moment due to this load, eccentric loading. Okay, so that is what this pre-stressing force 1000 into your PE, this pre-stressing force PE by this one. If you see how much it is, 1000 into your 50 by 1000. Wait, where is my this? 1 minute. Where is this? Am I sharing my screen? What is being shared? Am I sharing or not? I think screen is visible. Okay. Where is? Okay. Now at the midsection, what are the stresses which are developed? Will be your P by A, one direct stress. Then we have a stress due to the bending moment of all those dead load and the net load. Another one due to this eccentricity here of 50 mm, one bending moment due to this eccentricity will be present here, which is your this pre-stressing force into this E.